Hey guys, I hope everyone's doing well. In the last video, I taught you how to do confidence intervals for slopes. And in this video, I'm just going to rush through an example. And when I say rush, I mean really take our time. So let's read this really quickly. Scientists have long believed that linear regression could be used to predict the brain weight of non-human mammals from the body weight, okay? So in one study, body weight in kilograms and brain weight in grams of 22 non-human mammals were measured, and a linear regression analysis was performed, yielding the following output. If you watched the last video, you would know that we only care about this and this guy right here. No one else. Don't look at anything else, okay? So let's cross all of this off. Now, how do I write the equation of the line? Just for fun, it's going to be 68.688 plus 1.096, so these two numbers here, and then this is the x all the time, so body weight. And what is that equal to? Well, you can read it in our stem of the problem, or you can just look at it right there. It's body weight is x, brain weight is y, body weight is x. So we're going to do brain weight. So basically they're saying, depending on how much a non-human mammal weighs, that's going to predict the brain weight. Okay, so this is irrelevant to confidence intervals, but I just wanted to show you guys how to get the line of best fit. So conditions, assuming all conditions for inferences are met. That's amazing, but you still have to write the problem states the conditions are met, okay to proceed. Okay, that's step one. Step two is our formula, statistic plus or minus critical value times the standard deviation of the statistic, which is the standard error. We never are going to divide by the square root of n for this problem. We're only going to, okay, so once again, guys, this part here, after you use 68.688, you're never going to use him again. The only reason why we need him is for the equation of the line. That's it. Okay, so now we only got these two. So what do? This is my sample slope. This is my standard error. So here's your formula. 1.096. I went to my t. My t was 20 degrees of freedom. Okay, when I went to go look it up, it was 2.086 times the standard error, 0.1308. Just to remind you and not get you dizzy, 0.1308. 1.096, 1.096, 0.1308. You figure it out. You take 1.096 and you add it. You get this. 1.096 and you subtract it. You get this. Now here's your confidence interval, which is step two. Step three, our conclusion or our interpretation. Based on these samples, now remember, all you are doing is interpreting the slope, but over a range of plausible values. So based on these samples, we're 95% confident that for each additional one body weight, do you guys remember what one body weight is? For each x, body weight is x. So for each x, the y will increase by blah, blah, blah. So what is the y? Everything got to be in terms of the context, the brain weight, okay? So the brain weight increases by an average of 0.823. You could just put an N there, and 1.37, I believe it's kilograms as well. So once again, the interpretation is more important than anything. Based on these samples, we're 95% confident that for each additional, I know each and additional probably are interchangeable, but for each additional one body weight, the brain weight increases by an average of 0.823 to 1.37. So you're basically taking the slope and interpreting it for an entire interval, and that's how you do this problem. Leave a comment, ask a question, whatever you need, I'm here.